students, congratulations on finishing your first unit for this class. Unit 1, we talked about addition and subtraction word problems. We talked about how to add and subtract integers. Then we did some integer word problems, and then we finished up yesterday with the coordinate plane. So now that you've gone through all of those lessons, the next part is to pause and review the things we've learned in this. I have created this video, this PowerPoint, based off of the questions that students made the most mistakes with. In class, we always like to emphasize that mistakes are a part of learning. They're great because they're opportunities for you to learn. Lots of times there's been a student in class who goes like, oh my gosh, I can't believe I made this mistake. And I say to them, well, I bet you, like, based on that reaction, you're not gonna make it again, right? And they're like, oh my gosh, no, I'm so tired of making this mistake. So it's something that sticks with you, especially if it's a mistake you make a lot. But it's also great because we're now all gonna learn from the mistakes that a lot of students made in this lesson, or rather this unit. So to start us off, it may sound silly, but this was for sure one of the biggest reasons students got a question incorrectly is that they weren't reading the problem. They weren't reading the directions, they weren't reading what the question was asking. Especially with online learning, I think it could be a little more difficult because you have to read a lot during the day. But it is important to make sure you're reading everything we are putting in front of you because it's there for a reason. So directions for an assignment are important, but also when you start getting into the actual problems you're completing, these two things are really important. Make sure you answer what the question is asking. Sometimes I'll say, like, write an equation, and someone answers with the word positive. So if the directions say write an equation, make sure that's what you're doing in your answer. Simply like reading through the question one last time after you've written your answer to make sure it matches with what the question's asking for is a great strategy. Along with that, the other thing a lot of students messed up with is making sure you answer all parts of the question. Sometimes a question will have more than one part in it, and it could be all written together, but there might be two questions in that. So one of the most common things I'll do is I'll say, do you agree? Why or why not? There's two questions there. Do you agree? You should be answering yes or no. But then the second part is telling me why or why not. I could ask you a math question, but then ask you justify your answer. A lot of people might just give the math answer, but not justify. When I say justify, I'm saying like support your reasoning. Tell me where that answer came from. Again, those are two parts. That's gonna be the case throughout all of these math classes, not just the one you're currently in. So really making sure you're answering all the different parts, and we'll be here to keep supporting you as you do that. Now that we've talked about this, we can get into the actual math questions. From our first lesson, which covered addition and subtraction word problems, this is very similar to a homework question that a lot of people missed. So I've changed it up a little bit just so it's not the same question, but I do want to talk about it to make sure that we all understand what the answer is and why. So the question says, Raven wants to put twinkle lights around her backyard porch. She measured her porch and recorded the measurements below. The first part of this question asks, how many meters of twinkle lights will she need to go all around her porch? Go ahead and try that for me now. Well, the fact that they're saying all around her porch is a clue that we are talking about perimeter. Lots of times with perimeter questions, if you don't already have a picture, drawing a picture can help because it gives you a visual of what she's trying to do. Now, if we want to go all around her porch, you want to make sure you're going all the way around. She needs 20 on this side, she needs 32 on this side. That was a mistake students made, is they just stopped with the two numbers. But you've got to go all the way around, so she also needs 20 meters for this side, and she also needs 32 meters for this side. When you're calculating perimeter, you should be adding however many sides there are. If it's a rectangle, there's 4 sides, so you should be adding 4 numbers, which in this problem would be 20, 32, 20, and 32. After that, the rest of this is just some addition. 20 plus 32 is 52. That means this 20 plus 32 is also 52. And to together, that would give you 104. The other mistake some students were making is if you're asking a question about a distance, you've got to give what you're measuring with. Does she need 104 feet of twinkle lights, 104 inches of twinkle lights, 104 meters, or miles? We have to go back to the question and figure out what you're measuring with. In this case, M is the abbreviation we use for meters. The question also said meters, so just make sure you're answering 104 meters. Or you could even write a sentence saying Raven needs 104 meters. Now this is the first part of the question. The first part is how many meters does she need? She needs 104 meters. I'm gonna erase this to make room for the second part. The second part now says, one side of the porch is attached to her house, and Raven decides she doesn't need twinkle lights for that side. Based on this new information, could you tell Raven how many meters of twinkle lights she needs? Go ahead and try this second part now. The two most common answers I saw to the homework question that was similar to this was saying, well, yeah, she doesn't need one side. So we could say 20 plus 32 plus 20. Just add up those other sides. That's how much she needs. That's the strategy a lot of students used, but not everyone got rid of this side. Some students, instead of saying she doesn't need this side, said she doesn't need this side. We need to add 32 plus 20 plus 32. That's the answer. Well, does it tell us which side is the side against the house? It doesn't. It just said one side of the porch is attached. But I don't know which side that is. So I couldn't give you a number because I don't know if we should be taking out this side or taking out this side. So the answer based on this new information, could you tell Raven how many meters? You couldn't tell Raven that because we don't have a number. What you could tell her is a strategy to figure it out. If we know she needed 104 before, if the side that's against the house is the 20 meters, you just take out 20, you subtract 20. Or if it's this side, you just subtract out 32. So the strategy is there. You could say that, you could say, well, she only needs to add up the three sides that would have the twinkle lights, something along those lines. But based off of this, you could not give me a number. So if you were to add 20 and 32 and 20 together, which would be 72, 72 isn't correct because we don't have an actual number to tell her. We just have a strategy. Hopefully that makes sense. Like I said, this was a really big missed question on the homework, and I understand, right? You know the strategy, so you want to do the math, but if we don't know which side it is, we can't actually do the math. Hopefully this helps. I'm going to move on to the next question, which goes back to our lesson on adding and subtracting integers. What I've done is I made up two questions that are similar that try to incorporate a lot of stuff that we learned in that lesson. The question for both of these problems, and I'll kind of draw a line here, is which is larger? Use an inequality sign to compare the two amounts. So this is problem number 1, and this is problem number 2. So we've got two amounts here, and they're telling us to use an inequality sign to compare. I think part of the reason questions like this that ask for an inequality confuse students is based on answers. I think some people are mixing up the word integer and the word inequality. Integer is the name for positive and negative numbers. So when we talked about integers, I had shown you a number line, showed you this side is positive, this side is negative. All of these together are called integers. Inequalities are those statements that say less than or greater than. We use inequalities to compare two amounts. So what they're asking for in this problem is to use one of these inequality signs to compare how much is on this side with how much is on this side. Is this side less than this other side, or is this side greater than this side? Go ahead and try figuring out what inequality sign goes here now. All right. Well, if we go to do this problem, -3 plus 7, we talked in the lessons, there's a lot of different ways you can figure this out. That would give you 4 though. One way you can do it is say there's different signs, so I need to subtract, keep the sign of the bigger number. Some people in their written explanations sounded like a lot of people were thinking of money. This is like, I owe you $3 and I have 7, so I would pay you the $3 and then I still have 4 after that. Having money means it's positive. You can think about it on a number line. A number line, I'll put 0 in the middle. -3 is on this side. If you're adding 7, you're going towards the positive numbers, you're going larger. So adding 7 would look like you counting 3, 4, 5, 6, 7, which would end up at a positive 4. So many different ways to think about it. You just use the one that works best for you. But all that said, we do get 4 on this side for our final answer. Over here, when you've got 2 subtraction signs, 2 minus signs right next to each other like that, that becomes a plus sign. Subtracting a negative is the same thing as adding. So this would say -9 plus 2. It makes it a real similar problem to this one. Different signs, subtract, and then keep the sign of your larger number. That side ends up being -7. Being able to calculate both of these sides correctly is really important to figuring out what inequality sign we're going to use. Once you know that the left side is 4 and the right side is -7, then you can go ahead and say, well, 4 is greater than -7. So that greater than sign would be the answer. I know negative numbers and doing math with negative numbers is a really common thing for students to struggle with when they're first joining a math class. Again, we have so much practice on this, believe me. This classroom is filled with practice on integers. This is something you feel like you're struggling with a little bit, please reach out to me or Denise and we will be happy to give you some extra materials to practice with, or if you just want to talk through more of these problems with us, we are here for you. There is another problem though, right here. Go ahead and try this one. Same exact question. You're trying to figure out what inequality sign would we use to compare the 2 sides of that problem. And go. Well, how'd you do? For this left side, everything is negative, so we're just going to be left with a larger negative number. Over here on our right side, 5 minus 6, you're left with -1. For this one, if you're thinking about it with money, I owe you $2, I owe you another $3, now I owe you a total of $5. If you're using the rules, both negative, add, keep the sign. If you're thinking about it on a number line, -2 is here. Subtracting 3 means you're going backwards 3, so I would count 1, 2, 3, which would leave us at a -5. All good ways to think about it. Over here, if you're thinking of money, this is like, I have $5, I try to take $6 out of my bank account, well, it's gonna say -1 because I owe them $1. Rules, different signs, subtract, keep the sign of the larger number, and a number line. You're starting at 5, subtracting 6 is going backwards, 6, well, here would be 5, so then 1 more would get you to 6, and that would leave you at a -1. Either way, once you've got these 2 numbers, the last part is finding your inequality sign. This is the part that trips up students sometimes. -5 is less than -1. This was another of like the most missed questions on the homework. I know that 5 is greater than 1, which is why I think it's so confusing. But for negatives, remember the further this way on the number line, the smaller you're getting. You think about money, again, I keep going back to money. -5 is like you owe $5. You have less money if you owe $5 versus owing $1. So thinking about it with money, thinking about it with a number line, find the way that works for you. But yeah, I know these ones where they're both negative kind of take a second to think through. This is the practice I've got for adding and subtracting integers. Hopefully this is helping you feel like you understand it a little bit better. But again, if you've got questions, please reach out to us. The next part is using all of this to look at integer word problem. Now, a lot of our integer word problems we had talked about where you see negative numbers in real life. I saw a lot of you told me temperature and money, which is awesome. Some of you also said you see it at work, which is really awesome. I love when you can see negative numbers in your real life to help you make sense of them. A lot of our examples we worked through though were temperature and money, right? So I came up with just another example to give you another place where you could see negative numbers. So I've already kind of given you a clue for this problem. But our question says, Lucian, a Chinese mathematician, was born 50 BC and died 23 AD. And the question is, how old was Lucian when he died? Go ahead and try this one now. To figure out this answer, you have to know a little bit about BC and AD. When we're talking about years, I'm gonna kind of draw like a little timeline here, or a number line. But our timeline, right? We right now are in 2020. 2020 is actually 2020 AD. At some point, there was like a year zero, right? It's that middle part there. So we've got 2020, and it goes all the way back to a point in time where we've decided like this is the point in time where everything that comes after is AD and everything that comes before is BC. So when we're talking about Lucian, he was born 50 BC. That is before this point in time. So that would be over here. He was born 50 BC. I feel like I may be writing this too tiny for you to see, and if I am, I'm sorry. 50 BC, and he died 23 AD. So that would be on this side here. Everything from that point in time to the present we call AD, and everything before it is BC. We'll notice I've got 0 here in the middle, but 0 is not between 23 and 50. I said it's kind of, our timeline is kind of like a number line. I mentioned that and mentioned what I said earlier about places you see negatives, because BC is another place where you see negatives. If it's before that point, we've got it as a negative. When I was doing like research on this question, I actually found that they use negative numbers when they're in graveyards to like mark the year sometimes if it's BC. So another place you could see negatives, although hopefully not. Anyways, for this problem, I just wanted to show this is a place where you could see negatives. So we've got a negative number and a positive number, and we want to find how long he lived. Well, just looking at this number line, you could make an estimate how far apart these numbers are, because how far apart they are is going to be how long he lived. Go ahead and estimate how long he lived now. Remember, estimating does not involve doing any math. It's just a guess. So lots of times when people estimate, they round the numbers. So for example, instead of saying 199, I would say, it's easier just to say that's close to 200. Let me use 200 to do my math, to help you do it in your head. So go ahead, keeping that in mind, try to estimate how long he lived. Well, what did you say? A lot of people want to subtract these two. But if you look at this, he lived all of this time and then some more. Well, from here to here is 50, here to here is 23. We actually want to add those together. What you're really doing is taking the year he died and subtracting the year he was born. You're finding the difference in those years. Just like if I was born in 2000, I was not. If I was born in 2000 and then I died this year in 2020, which I'm not planning on doing, I would want to subtract 2020, the year I hypothetically died, from the year I hypothetically was born, to see, I was 20 years old. It's the same idea. We're taking the year he died and subtracting the year he was born. Now I chose this problem in particular, one, because it's a new example we've never seen before, so I think that could be helpful, but also for this idea right here, these double negatives. We had seen something similar in that question where there was the top of the hill and the bottom of the lake, and I asked you to find the difference. It's the same idea as that. We're finding the difference, which is why it's subtraction, the difference between those 2 years. I'm just realizing it says 20, but this is year 20, 3, so I'm going to change that. The last part of this is doing the math. What are we going to have to do with these numbers? Well, we mentioned before that he lived all of this time plus this time, so we wanted to add those numbers together. We had learned in the lesson before this one that 2 subtraction signs changes to an addition sign. So we get 23 plus 50. If you put those on top of each other to add, you can do that, but that's going to leave you with 73. He was 73 years old, approximately. You know, there'd be some months in there too to calculate if you wanted to know exactly how old he was. But approximately 73 years old, which is really long considering how long ago it was. So good job, Lucian. Hopefully you found these examples helpful as you're looking over all the stuff you've learned in Unit 1 and reviewing. You are watching this on Wednesday. On Thursday we'll have an assignment we give to you that's got questions from each of these lessons just to see where you're at as far as Unit 1 goes. Hopefully you found this video helpful. Thanks. Bye.